Yeah, comes on everyone. Let's start off. Perfect. So last thing we did was this individual process we are doing. Great. So we have isochoric, isobaric, isothermal, adiabatic, polytropic. Delta U, work done, delta Q, molar heat capacity C का value, yeah. The relation between pressure, volume, and temperature. There. Can you fill up the table? Fill it up. I'll give you 2 minutes. We have derived results for all of this. This is what I was saying. You should know delta U, work done, and delta Q for each process, U and molar heat capacity. Once you know this, you'll be able to handle most of the questions. Let's say delta U is the best. NCV dt, NCV dt, 0, NCV dt, NCV dt. Right? Independent of the process, it is always the same. And CV is FR by 2. And CP minus CV is R. So the other two things you should know. What is work done? 0. What is delta Q? NCV dt. What are motor heat capacity? CV. What is the relation between PV and T? Here volume is constant, so P is proportional to T. Isobaric. So work done is P delta V or NR delta T. What is this? NCP delta T. So CP is CV plus R. This is CP. This is V proportional to T. Isothermal nRT ln V2 by V1. This also will be same nRT ln V2 by V1 because delta Q is delta U plus W. Be careful with that. There is a chance you can get confused between your chem and physics ka thing. So this guy is infinity. This is PV is constant. This is P2, V2 minus P1, V1 by 1 minus gamma or NR delta T by 1 minus gamma. Delta Q is 0. This is 0. This is PV power gamma is constant. TV power gamma minus 1 is constant. P power 1 minus gamma, T power gamma is constant. Work done here would be same thing, P2, V2 minus P1, V1 by 1 minus X or NR delta T by 1 minus X. Delta Q is NC dt. C is CV plus R by 1 minus X. So here this would be a better one. dq is to du is to dw will be in the ratio of C is to CV is to R by 1 minus X. And here the relation PV power X is equal to constant. We'll get a similar relation. TV power X minus 1 is equal to constant. And remember gamma is 1 plus 2 by F. Clear. You should know the results. Next one. So these are the 5 processes. Out of this, there is a 6th process. Free expansion. Consider we have a container with a membrane. So one side is filled with a gas, P naught, V naught, T naught. The other side is vacuum. No. And the whole vessel is insulated. Now what you did, you suddenly removed the membrane. When the membrane is suddenly removed, now what will happen? All these molecules, right? They will just start going to the right. It's like a flood. Now, because the right side is vacuum, there is no opposition. There is no one to stop you. Now, if there is no force which is stopping you, then what is the work done? Zero. right? Someone should resist you, no? If there is no opposition, nothing, you're just passing through, then there is no work done. Now, the other problem here is during this instant, pressure and temperature are undefined. Why? Here, this is vacuum. Here, there are some molecules. What is pressure and what is temperature here, isn't it? If you remember, the whole PV is equal to nRT ka story comes only when the whole gas is uniform. So here, momentarily for some time, P and T becomes undefined. You can't use ideal gas equations. Then eventually, whole thing will settle down. The gas molecules will distribute everywhere uniformly. Now, this is the best part. Since the whole container is vessel is insulated, delta Q is zero. We proved work done is zero. Therefore, delta U is zero. All are zero. So these gas molecules will spread out. The pressure becomes half. Volume becomes double, assuming the container is 2 times the size. Temperature remains same. Because delta U is zero, temperature doesn't change. The internal energy remains the same, but yeah, pressure becomes half and volume becomes double. Clear with this? This is one of the nice process. All are zero. Easy to remember. Other than that, there is nothing like also. Now in this, they can do one more thing. Instead of removing the membrane, let's say you puncture the membrane, you make a small hole. Now, the moment you make a hole, what happens? The gas will start leaking out of this. Now, the thing is, the moment the gas leaks, it starts occupying the space on the other side. So there will be some molecules here. These things will oppose. You're getting the moment little gas goes to the right side, the whole right side gets occupied, and that will start pushing the gas which is coming. Able to visualize how it is? So the gas molecules which entered on the right will start opposing the molecules which are coming from the left. Happens, na? You have an empty classroom and the students are going in. Ever been into a plane? You start getting into the plane and you start getting stuck in the corridor because someone is putting the luggage, someone is stopping there, someone is chit chatting, someone is chilling out, anything, right? Someone is confused with the seat, so things get blocked up. So there is an opposition here. So it's like an internally there's a fight. So leaked gas is opposing the incoming gas. So this does negative work. This does positive work. It's pushing. So if you see at any instant, dW is not zero, but network is zero. So initially the left gas will push with more. Container has to be insulated. The heat will escape out, nare God. But again, same story. It'll come back to the same state. It doesn't matter what you do. You remove the membrane, you remove the, make a hole, you will come to the final state is the same thing. Because internally the work done is zero. The delta Q is zero because the whole vessel is insulated. Heat can't escape out. Delta U has to be zero. The only difference being here work is zero at every instant. Here work is not zero at every instant. So some points it is positive and eventually it is zero. Possible to repeat. No, the membrane you are making the hole, right, Akshay? You puncture the membrane. Gas didn't puncture the membrane.
So like if the gas is flowing, then if it flows at a high speed, then it could like
It is at rest na here. The gas is in a container. Then there is a membrane which is blocking it. No,
okay.
it's not like gas is flowing in a pipe or something. I understand what you're saying. वो नहीं था ये. Clear, everyone. So this is a very cool process. All are zero. Very easy to remember. These are the 6 processes. Clear with this. The next step. All clear? Devansh? Here? Arush? Pratik? Great. Next thing. Efficiency of a cyclic process. So the efficiency ka definition is what? Output by input. So this is the symbol we use for efficiency. Eta. The efficiency is nothing but the total work done in a cyclic process. By the positive heats or the heat given to the system. Kind of makes sense. Meaning, if I give you 100 joules of heat and you do only 20 joules of work, then the efficiency is 20%. So we consider only the positive heats. The negative heats, meaning they got heat rejected. These are rejected heats. Think of like this: in a steam engine, when you put some coal to burn, all that smoke that is escaping, all the heat that is escaping, from the container ka walls, these heats you cannot recover them. These are all negative heats. So you're only interested in the positive heat. How much heat did you give and how much work you did? Okay. Great. Let's see a question. Let's do one or two easy questions, then we will go ahead. Hmm. Let's get them both. Temperature of 1 mole of an ideal gas is increased from 300 to 310 under isoporic process. And heat supplied to the gas in this process was 25 hard. What amount of work has to be done by the gas if the temperature of the gas decreases from 310 to 300 adiabatically? So there are two parts of the question. One is isocoric, one is an adiabatic. And if you observe something in the question, he didn't tell you what kind of gas is this, monatomic, diatomic, kuch nahi mention kiya. That is the reason he gave you that initial process to figure out that CV or something. Think, I'll give you a minute. Get the second one. Second one is a straightforward formula substitution. Right, Ishana. You got the first part right. Let's see. 375. Okay, let's see that thing. Now, in the first process, the gas cut temperature is going from, so in isochoric process, dW is 0. So dQ was du, which is NCV dt, and he's saying this is 25 R. So N is 1 mole, CV I don't know, dt is 10, is 25 R. Perfect. Now in the adiabatic process, delta Q is 0. So work done is minus delta U. Now remember, delta U doesn't care. It always depends only on the NCV dt. So here it is minus 1 CV. dt here is 300 minus 310. So that is plus 10 CV, which is 25 R. That's your answer. It's 25 R only. Clear. What about this thing? Here an ideal gas at 25 degrees compressed adiabatically to. So if you see in this, they're talking about temperature and volume. So T1 V1 per gamma minus 1 is T2 V2 per gamma minus 1. Initial temperature is 300. Be careful, temperature should be in Kelvin. This is volume gamma minus 1. T2 is asking the rise in temperature of the gas is T2 and adiabatically to 8 by 27 V power gamma minus 1. Gamma is 5 by 3 minus 1. We will cancel. That's T100, T2, and this is a 2 by 3 whole cube into 5 by 3 minus 1 is 2 by 3. So that is T2, 2 by 3 ka square, 4 by 9. So T2 will be 2700 by 4, which is 27 into 25, which is 675 Kelvin, right? So he's asking the rise in temperature. So the change in temperature would be 675 Kelvin minus 300 Kelvin, which is 375 Kelvin or 375 degrees, both are same. Change, it won't matter whether you're taking Celsius or Kelvin. The difference will remain same. Clear with this? Straightforward formula substitutions. Next one. Any doubts on this? Clear, na? Devika, Ansh, Nikhil, Sharman. Okay, next one. In the ABCD cyclic process, you have seen this before. N is equal to 1, and this is a helium gas. First one, find temperature at A, B, C, and D. That's an easy one. AB, BC, CD, DA, delta U, work done, delta Q. Fill up this table. So in each process, I want you to tell me what is delta U, work done, and delta Q, and find efficiency. Now, in the exam, they'll ask you find efficiency. Then literally have to do A and B part. There, get them all. Yeah, temperature is easy. Get the efficiency. Let's see the first part. Now for temperature, it is PV by NR. So temperature at A is P naught V naught by R. This is also the temperature at where temperature at B is 2 P naught V naught by R. This is also the temperature at D. Temperature at C is 4 P naught V naught by R. Perfect. So first thing, once you got temperature, the next easiest to find is what? Delta U. Always I'm telling you, see. Tell me one thing. Listen to this thing. What is delta U? NCV delta T. Agreed? Now look at the work done. Isobaric, what is work done? NR delta T. Adiabatic, what is work done? NR delta T 1 minus gamma. And isothermal, what is work done? NRT ln V2 by V1. Did you observe one thing? In everything, there is something common. Temperature. Whenever they ask you to find efficiencies, if you know the temperature of all the points, you will get everything. You'll get work done, delta U, everything will follow up. So in our question here, so delta U is F by 2 NR delta T. F is 3, N is 1. So this is 3 by R delta T. So what is delta U AB? So delta U AB is 3R by 2. Delta T is TB minus TA. TB minus TA is P naught V naught by R. So that is 3P naught V naught by 2. There. So this is 3P naught V naught by 2. Similarly, I can do between B and C. That would be 3P naught V naught. Then I can do between D and C. That would be minus 3P naught V naught. Then I can do between D and A. That would be minus 3P naught V naught by 2. Check. And you will notice something here. If I add all this, I should get 0. Obviously, in a cyclic process, if you come back to the same state, your initial and final temperatures are same. Delta U will be 0. So that is one way to check in case you didn't go for. Next thing here, you can clearly see AB and CD are isochoric. So therefore, AB ka work done 0, CD ka work done is 0. BC and AD are isobaric. So I can use P delta V, which is 2P naught V naught, and this guy is minus P naught V naught because the volume is decreasing. Once you got this, it is done. Delta Q is nothing but delta U plus W is delta Q. Now, that is one thing. Generally, if you want to find delta Q, it is always preferable you find delta U and Q. Right, Daksha? This is 3P naught V naught by 2. This is 5P naught V naught. This is minus 3P naught V naught. This is minus 5 by 2 P naught V naught. From this, we get total work. You can just add all the works, which is P naught V naught. And in this, if you see, this is the positive heat, this is the positive heat, these are negative heats. So efficiency is defined as total work by only the positive heats. You don't consider the negative heats because they are the heats that escaped out. You can't recover them. So total work done is P naught V naught by positive heats is 3P naught V naught by 2 plus 5P naught V naught. This guy is 2 by 13 into 100 percentage. What is the meaning of that? For every 13 joules of heat that you supply, only 2 joules become work. So 11 joules is wasted. Is this clear, everyone? Efficiency what? If they ask you efficiency, you need to draw the table. The reason being, just by looking at the diagram, can you tell me which heat will be positive, which heat will be negative? You can't see and tell. So in order to be sure, you have to be heavy that. Clear with this? All got what we did? Let's see one more like this. Let's see one more. So the previous question was isobarics and isochoric process. Every time you won't get PV graph only. I can even give you a VT graph. This is a line passing through origin. T naught to T naught, V naught to V naught. This is A, this is B, this is C. Same story, N is 1, helium gas. AB, PC, CA, delta U, work done, delta Q. Fill up the table. And find efficiency. Same steps. Here, luckily, temperatures you already know. Try. Everyone should try. Go just give it a try. Then try. Your headphones look pretty weird. They're very distractive. Well, that is okay. Everyone should continue sending your daily study reports. Some of you are sending, some of you are not sending. Do keep sending, helps a lot. That report is not for me. When you're typing that report and sending, you will know what good things and what shit things you did on the same day. So you will find better ways to improve it. So do keep sending. Yeah, give me the efficiency, no, Miha. If you got that, then everything falls in place. Delta U is the most easiest one to do, Ray. Why are you giving answers for that? Get the remaining. You're behaving like my sister only. When you put food and sweets, first she will eat the sweets, then she will say the other food is not good. Ever seen your kid sister or kid brother doing that? You eat all the best parts of the food and you throw the rest of it. It's like paneer salad, you eat all the paneer and then say salad is bad. Delta U is like that. Get the remaining. Get the efficiency. Try. I'll give you another 1.5 minutes. $54 by 69. That is such a beautiful answer, which is wrong. How the did you get work done in isothermal process without a lawn? Devansh, God.
सर लॉन को अप्रोक्सीमेट किया वैल्यू.
But Shama, ठीक है. You are the God only. Re. Keep it in lawn only. Re. You're pretty high efficiency. Re. फिर भी बहुत ज़्यादा आ गया. नहीं? I hope you didn't take ln 2 को log 2 करके 0.3 नहीं डाला. Okay. Someone got 2 plus ln 4 by 5 plus ln 4. Nee, Puroja, you're goofing up. You should take only positive heats. Denominator में ln नहीं आएगा. See. So for A to B, what is A to B here? Which process is this? A to B is isobaric. B to C, isothermal. So that is the first thing actually. Figure out which process is what. C to A is isochoric. Perfect. So in isochoric work done is 0. In isothermal VC is 0. Now see, this is the best thing, huh? That looks right, Ansh. Let's see. So it's like kind of a puzzle only. You can fill up, few blanks and you'll get the remaining. Now when you go from A to B, isobaric process, what is delta U? NCV delta T. So F by 2 nRT. So 3 by 2, N is 1. R. So A to B delta T is T naught. Now this will be minus 3 by 2 R T naught. Now there's no need to solve. Why? This has to be 0. Is that making sense? The total delta U is 0. So there's no need to solve for CS separately. What about work done? nRT naught. Remember, this is a VT graph. This guy will be 5 by 2 nRT naught. This guy will be nRT B to C na. So this is nR2 T naught ln V final, that is ln half. This also will be, this will be minus 2 nRT naught ln 2. Isochoric, this will be minus 3 by 2 RT naught. So the efficiency will be, the total work done is nRT naught minus 2 nRT naught ln 2 by only the positive heats is 5 by 2 nRT naught. nRT naught will cancel, 2 into 1 minus 2 ln 2 by 5. Check. How did you get PV? Where is P in the whole question? Can you see P anywhere here? Show me P in one alphabet anywhere here.
नहीं सर वो सब्स्टिट्यूट करना था वो भूल गए.
If we maintain ln half, then it will be positive. Right? Ln half is a negative number, na, God. How can it be positive? For number end of the day, that is a negative only, na. It's like minus 2 ko you're writing plus of minus 2. It doesn't become a positive number. Yeah. This is minus 2 nRT naught ln 2. Clear? Did you notice something? If you know the formula for each process question, answers will come. That's the thing I was saying. You need to know your results. Clear, everyone? Next one. Devansh.
Efficiency negative आ रहा है.
ठीक है ना, मतलब it is such a hopeless process, right? That first of all it will take all the heat and ऊपर से it will take work also. It will not give you anything in return. Your refrigerators have negative efficiency. सोचो, a refrigerator, right, will absorb electricity, so it is absorbing work, right? And it is giving you out heat instead of taking heat. The refrigerators have negative efficiency. So it is some kind of a weird cycle. Next one. This is a good one. This is A, B, C. This is V naught. This is 4V naught. Gamma is 1.5. Right? Tn is equal to 1. It actually won't matter. Now in this, so in the process A, B, C, A, we have isothermal. Now they didn't tell you which one is isothermal, which one is adiabatic. So you have to figure out. We have isothermal, we have adiabatic, and we have isobaric. Which one is which? We don't know. Examine that. It was a mains question. Identify the processes. The first thing, identify the process. Second thing, find the volume at C. Third, find efficiency. Now, the moment I say efficiency, you have to fill up the table. Get them all. I'll give you 3-4 minutes. Do you guys remember last time I told you, which is adiabatic and which is isothermal? Slope of adiabatic is more steep. It gets closer to 90 degrees. PO क्या होता है? Only this much information you have. You don't have more. Someone wants pressure also now. You won't get so much. Get it. AB is isobaric, BC is adiabatic, C is isothermal. ठीक है. You can see from the slope here. This guy ka slope is here, and this guy ka mode is more flattish. You can see AC is more flattish, so that is isothermal. Find VC and get the rest. Get them. I'll get 3-4 minutes. It's a good one. If you got this on your own, I think you figured out efficiency part. Find VC. Without that, you won't be able to go ahead with the table. You'll get stuck. VC is the key. It's a good question. Meaning you can even make it a paragraph or a more than one choice question. The whole question looks like you don't have enough data, but you have enough. नहीं Shana. Double of that actually. Check kar, you missed a 2 somewhere. It should be double of what you got. C is equal to V naught means you know what happened? This C here, it came back here. This is the process. You created a new process. That looks interesting. It has to be more than 4 V naught, right? इतना तो clear है. Let's see. So first thing is clear. AB is isobaric. BC is adiabatic. CA is isothermal. Now, you don't know anything here, but remember just now I told you, if somehow I can figure out the temperature, or if I know temperature, I can get everything. So we don't know temperature also here. Let's start with an assumption. Let temperature at A be T naught. Now, I don't know what is T naught, so I have to eliminate this. Right, Nikhil, you got it. That is the volume. So A ka temperature is T naught. Now look at this. Now, if that is T naught, what is the temperature at C? Temperature at C is also T naught. Why? It's an isothermal process. Perfect. Then in the process A to B, it is isobaric. V is proportional to T. So VA by VB is TA by TB. This would be 1 by 4, and this is T naught by TB. So TB is 40 naught. There, I found all the temperatures in terms of T naught. Nay, VC is 64 V naught, everyone. Now, you want to find VC there. Now, if you go from B to C process, it is adiabatic. So you can clearly see, I know the temperatures. I need to find the volumes. So TB, VC, TB, VB power gamma minus 1 is TC, VC power gamma minus 1. TB is 40 naught, VB is 4 V naught, gamma minus 1 is half. TC is T naught, and VC gamma power is half. T naught will cancel. This we square it on both sides. That would be 16 into 4 V naught is VC. VC is 64 V naught. Perfect. There. So I know the volumes I roughly have an idea about temperatures, T0, T0, T0. Now you need to fill up the table and get the efficiency. Now can you try? I'll give you 2 minutes. Fill up the table. Like I said, once you know the temperature, you can literally find everything. T0 I don't know. So efficiency ka final answer mein T0 should not be there. Thermo is one chapter, right? Unlike rotation or mechanics, there is really very less to think. You know the formulas, you know the process, you just brute force, you just keep putting and solving. Things do fall in place. Fill up the table, fill up the table. Everyone should try. Hmm. 9 minus ln 64. You can make that 2 power 6. Right, Ishana, that is right. Let's see. A to B. One thing here. Now, gamma is 1.5, which is 1 plus 2 by F. So here, if you see F is 4. So this must be some kind of, one mole of monatomic and 1 mole of diatomic gas. Right? So it must be a mixture of something like that. So here the formula is F by 2 NR delta T. F is 4. That is 2 will become 2 NR. N is not given. Delta T is 3T naught. This is a NR 3T naught. NR delta T, work done in isobaric process. So let me write that thing. So AB is your isobaric. BC is adiabatic. CA is isothermal. So this would be 0. This will be minus 6 NR T naught. This is 0. So automatically this work will be 6 NR T naught. You're getting it? This is what I was saying. There's no need to solve. If I know delta U and if I know delta Q is 0, then delta U is equal to minus delta W. This is a 9 NR T naught. This would be NR T naught ln V final. V final is V naught by 64 V naught. That would be 64 is 2 power 6 minus 6 NR T naught ln 2. This is also minus 6 NR T naught ln 2. Yeah, done. So efficiency total work will be 9 plus 3, 9 NR T naught minus 6 NR T naught ln 2 by only the positive heats. 9 NR T naught. NR T naught will cancel. 9 minus 6 ln 2 by 9. 3 also will cancel. 3 minus 2 ln 2 by 3. Check. Any doubts on this? Check out the steps. Clear? Let's see one more. Any doubts on this? So if they ask you for efficiency, right, you can just start with something as T naught and you can figure out everything. The T naught does cancel out. Let's get this. This was a 97 ka question. Even that time it used to be subjective. First, can you draw the graph? First, draw the PV graph and then find the temperature of the gas at B and D and then find efficiency. For efficiency, you can just write the equations and leave it. No need to simplify. First, draw the graph and find the temperatures and fill up the table with the formulas. It's fine if you don't simplify this. Draw the graph. That's an important one. Did you guys get the graph? See how it looks. So 1 mole of an atomic gas cyclic process from AB is an adiabatic compression. So you have to go in the reverse. And then BC is isobaric expansion. And then CD is adiabatic expansion. And DA is isochoric. So D will end somewhere here. This is how it looks. And he mentioned temperature at A is 300 Kelvin. And it is also given this ratio of volumes are given. So using this data, you have to find temperature at B and D. If you want efficiency, temperature at C also you have to find. So yeah, get temperature at BCD. If you got that, actually question is over. Get it, I'll give you 2 minutes for temperature at BCD. Did you get the temperature? There, if you see, there are some values, 16 power 0.4, 1 by 8.4, you have to use them. Hmm, 909. Right, Niharika. Let's see. I already know A. Now, if you see A to B is an isobaric process. You can clearly see volumes are given, temperature you're asking. So the equation is TA, VA per gamma minus 1 is TB, VB per gamma minus 1. So TA is 300, VA by VB will be 16 to the power of gamma minus 1, that is 0.4 is TB. So that is 3.303 into 300, 909 Kelvin. Now, when you go from B to C, it is isobaric process. So VB by VC is equal to TB by TC. VB by VC is 2, TB is 9, VB by VC is half, TB is 909 by TC. So TC is 18 Kelvin. Now when you go from D to A, again C to D, that is also an isobaric process. TC VC par gamma minus 1 is TD VD par gamma minus 1. Now I have two things there. VA by VB is 16. VC by VB is 2. If I divide them, I end up with VA by VC is equal to 8. And do remember, we also know VC is equal to VD is equal to VA because it's an isochoric process. So TC is 18. This guy is VC by VA, whole power 0.4 is TD. That is 1 by 8. So 18, 0.435. How much ever is that you can calculate? 791 K. There. There you got all the temperatures. Check your steps. Again, like I said, you should know what process is this, what information is given, use the appropriate formula, get the answers. Clear? Any steps that I didn't get here, please ask. Next thing. Now we have to fill up the table. Now, if you see BA and CD, BA and CD, these are 0. AD work done is 0. So A to B, delta U will be NCV delta T. It's a diatomic gas, so I can figure that out. NCV TB minus TA. So delta Q now, so this will be minus of delta U, isn't it? There's no need to actually separately calculate. You can finish off with that. B to C is NR. This also will be same. NCV TC minus TB. This will be NR TC minus TB. This would be NCP TC minus TB. It's an isobaric process. C to D, that is 0. So this is NCV TD minus TC. This is minus delta U. D to A, NCV TD minus TA. This also will be NCV TD minus TA. We know the numbers. We can substitute and check it out. So we will leave it here. Work done by positive heats. So you have to substitute the numbers and check who is positive and who is negative for the Q. Clear, everyone? Yeah, so this is one type of questions. Next one. Let's see one more. So in a process, du is 3 times dw. It's a diatomic gas. In a process, dq is du by 2 plus dw by 3. Remember, no matter what kind of process I give, PV is equal to nRT is valid and dq is du plus dw is valid. So in this question, it is being mentioned. Other than this, these are being satisfied. These are two different questions. Find molar heat capacity. How do we proceed with these kind of questions? Let me help you with one. Look at the first one. We know dq is du plus dw. Now you are saying dw is du by 3. So dq is 4 by 3 du. So dq is nc dt. That's what you want to find. And du is ncv dt. Done. So C is equal to 4 Cv by 3. Cv is Fr by 2. It's a diatomic gas, so 5R by 2. That would be 10R by 3. Check. Easy. So the main thing is that. So get dq in terms of du and your job's done. Same thing you do in the B also. So eliminate dw actually. You'll get it. Get the next one. I'll give you a minute. Idea is the same. What is the answer for this? Try. 13R by 12. Anyone else got this? See, so dq is du plus dw. So dw will be 3 times dq minus du by 2. Expand this. So basically, I took dw from here and I substituted there. Let me write down one time for you. So take this guy and put it in this. This will be minus 2 dq. This will be du by 2. So this is 1/4 of du. So nc dt is 1 by 4 ncv dt. So dt is 1 by 4 fr by 2. It's a monatomic gas, 3r by 2. 3r by 8, na? Yeah. See where it went wrong. 13-bit, well, how did you get right? 2 people. What did you guys do? You took diatomic, yeah? फिर भी 5. Why can't you take PdV as NRT? अरे PdV NRT नहीं है God. PdV plus VdP is NRT. Who told you isobaric process? This is not an isobaric process, right? Clear, everyone? So if you see, this is again one model. It took diatomic, okay. But you can't take PV as NRT. Clear, everyone?
सर इधर माइनस साइन आना चाहिए
कहाँ पे?
सर अपने वो नहीं सर कुछ
Next one. An ideal gas undergoes adiabatic process where CV is given by A plus BT. So your CV is not constant. A and B are constants, T is temperature. That means as the temperature increases, CV increases. You know, how is this possible? This kind of situation, right, can occur. Again, this is just for discussion. Let's say if you take a container having oxygen gas. Now, as temperature rises, what will happen? The molecules will start dissociating. As temperature rises, they can make like this. Molecules dissociate into atoms. So they'll become atomic oxygen. So your gas becomes a mixture of O2. So there are still some O2 molecules, but now you have some atomic oxygen also. Now see what happens. If you take an O2 molecule, how many degrees of freedom is there? 5. But if this breaks down into O and O, how many degrees of freedom are there? 3 translation, 6, no? Did you see what happened? So degrees of freedom is getting messed up because the molecules are dissociating. So something like this is happening. Getting it? Exact scenario we don't know. So the number of degrees of freedom increases. So we'll not get into more, but there, such a thing can happen. So CV is not constant. Find relation between temperature and volume. Now be careful. That relation which we have, TV power gamma minus 1 is constant. This was derived when CV is FR by 2, which was constant. So this result is not valid here. How do we do this? You're getting how this is possible, right? The CV can change. So that is just to give an idea. If this comes in the exam, how do you guess this? How do we guess this? When someone tells me A, B, T, so many variables are there, first thing that I think is always guessing only. If you give me numbers, then I know I can't guess. But if you give me a lot of variables, there is a way to guess this. Anyone? Think. Take 10, 15 seconds first. Think about how to guess this. Solving is fine. Subject is fine. You need to understand just because you're good in solving questions doesn't mean you'll do well in the exam. Put a value and check. What value will you put and what will you check? Tell me. ये बोलना easy है. Put a value and check. What will you put and what will you check? Taking A, Neresh, Shana, you said the wrong thing. Should take B as 0. Then what happens? If B is 0, CB is constant. Then you should get back this answer, na? You're getting the point? If you take B as 0, you will get your standard equation. Now in the options, put B 0 and see who is giving you TV per gamma minus 1. Right? That is what I mean by guessing. So, Puruja, what you said, that is how you solve. Try to solve. Think, I'll give you 2 minutes. Answer is bad. It doesn't look great. Think, 2 minutes. Show you. See. Now, like I said, remember the two equations are always there with you. PV is equal to nRT and the thermodynamics first law. So we have CV is A plus BT. dq is du plus dw. It's an adiabatic process, so this guy is 0. This is ncv dt plus pdv. So we have ncv dt, that would be minus ncv is a plus bt dt is pdv. But we also know PV is equal to nRT. So one thing, if you realize, I'm asking you between temperature and volume. That is a hint that, boss, I don't want pressure. So let's eliminate pressure. P is nRT by V. Substitute here. And this is minus Na plus Pt dt nRT dV by V. N goes off. Send T also this side. Minus A by T dt minus B dt is equal to R dV by V. Integrate. This is minus A ln T minus Bt. This is R ln V plus some constant. I can send the minus that to bring all the terms to this side. So this would be R ln V plus A ln T. This will be some constant minus Bt. You can just multiply minus sign, doesn't matter. Constant is any constant. This guy will be ln V power R ln T power A is some constant minus Bt. Send E that side. So V power A, T power A is E power constant minus Bt. Bring it this side. So V power R, T power A, E power Bt is equal to E power constant is constant. There, that's your answer. Option should be like this only. V power R, T power A, E power Bt and all this stuff. So this is the relation between volume and temperature. Doesn't look that great, but yeah. Clear, everyone. Have a look at this. Take a break. Come back by 7:10. Any doubt so far? Okay, come back in 10 minutes. Next one. Let's say we have a container. And the whole thing is insulated. We have a heater. So here the pressure is P naught, volume is V naught, temperature is T naught. Here also P naught, V naught, T naught. So basically both the sides are identical. This is a smooth, massless, movable insulated piston. Means it is free to move, right? It is massless, it is insulated, yeah, and it is free to move. Now what happened when the heater is switched on? The piston will move. So it's switched on for some time. The pressure in the right compartment becomes 243 by 32 P naught. So you switched on it for some time, then you switched it off. So in this process, what will happen? The left side ka gas ka temperature will increase. If temperature rises, pressure will increase. If pressure increases, it will push the piston. You're getting what is happening? So the piston will move to the right side, and in turn, the pressure increases. Find the final temperature of the gases in both the compartments. Find the final temperature of the gases in the compartment and find the heat given by the heater. So how much heat is given by the heater? There, this is another type of questions. Like I keep saying, what is the first thing? Draw the final state. Ask yourself a few questions. Okay, the pressure on the right compartment is this. What will be the pressure in the left compartment? What will be the volume? What will be the temperature? Will it be same? Will it be different? What kind of process is the right gas undergoing? What kind of process is the left gas undergoing? If you can figure out the process, then you know what formulas to use. Think. Take a minute to figure out the basic. Then I'll give you some information, and then I'll give you some more time. See. Now, let this be 243 P naught by 32. Let the volume be V2, let the temperature be T2. Now here also pressure must be same. Did you figure that out? Let the volume be V1, let the temperature be T1. Why? Because the piston is smooth. If it is an equilibrium, if this side is P1 into area, this is P2 into area. Since there is no friction, there is nothing, P1 must be equal to P2. That is the first part, that the pressure on left and right is same. And here the volumes are different, but you will notice V1 plus V2 is 2V0. Total volume is constant now. That much we know. Next thing, now see, this whole thing is insulated, isn't it? That means heat doesn't enter, doesn't leave. So the right compartment is undergoing adiabatic compression, isn't it? That was the second information. The right compartment undergoes adiabatic compression. What about the left compartment? Left compartment, the heater is giving you heat, so it is not adiabatic. The temperature is not going anywhere, so temperature is changing, it's not isothermal. Pressure is not constant, volume is changing, it is nothing. The left gas compartment is nothing. So if it's an adiabatic compression, again, you need to ask yourself, what is being given? Pressure is given, you're asking for temperatures. So we have to use the relation P power 1 minus gamma, T power gamma is constant. You can write this thing as P power 1 minus gamma by gamma is T is equal to constant. There. And did I tell you what gas it is? I didn't tell you, I forgot. This is helium gas. There, I give you all the information. Now can you try? I'll give you 2 minutes. Now can you find T1, T2? This is the first part that you need to figure out. That P1 is equal to P2 and V1 plus V2 is 2V0 and the right side gas is adiabatic compression. Now comes solving. Try. Your seniors are super tense, huh? Next Wednesday is start or engage. Let's see, what is gamma here? 1 plus 2 by 3, 5 by 3. So 1 minus gamma by gamma is minus 2 by 5. So initially P naught minus 2 by 5, temperature is T naught, is finally is 243 by 32 P naught minus 2 by 5 into T. 2. P naught will cancel. 243 is how much? 3 power 5 by 2 power 5. So this is 3 by 2 whole power 5 into minus 2 by 5. 5 will cancel. This will be 4 by 9. So 9 T naught by 4. There. That was the reason that number is given 243 by 32. It gets cancelled out neatly. There, I got T2. Now how to find T1 and how to find the heat? Think I'll give you a minute more. Moles भी कंसा कर सकते हो, but don't you have too many variables, right? P, V, T. P पता है. You don't know V and you don't know T. You have two variables. How will you find? P1, P2 plus 2 V naught plus N1. Can you say that? Think about it. When you write PV is equal to nRT, what is P? P is the pressure in the volume V, isn't it? So think. What you did was simply moles conservation. You did nothing new. What are the second part? Now for the same thing, right compartment. I can use the number of moles ka thing. P naught V naught by T naught is 243 P naught by 32. Volume is V2 by 9 T naught by 4. So from here we'll get V2 is equal to, that is 27. So 8 by 27 V naught. There, I got V2. So what? I can find V1 from here because V1 plus V2 is 2 V naught. V1 will be 2 V naught minus 8 V naught by 27. That is 46 V naught by 27. Okay, but I don't want this. But I got something else. I got the volume in the left compartment. Again, I can use mole conservation. P naught V naught by 2 naught. The pressure is same. 243 P naught by 32. Volume is 46 V naught by 27, and this is T1. There, solve this, I'll get T1 from here. Is this clear, everyone? 414 by 32, yeah? Check, the numbers don't look that great, but you got it. Clear? There I found T1, T2. Now how to find the heat? Now listen to this thing. Now, whenever they ask you to find the heat produced, you need to actually see where is all this energy going. So when you're heating this, where is all this heat being absorbed? Tell me which compartment is taking all the heat? The left compartment. No, heat cannot directly go from left to right. No? So heat is being taken by the left compartment. Okay. What did the left compartment do with this? It took some of its energy and used it to change its own internal energy. Fair enough. And what did it do with the remaining energy? It pushed the piston. It is used to move the piston. Basically, it did work on the piston. And what did the piston do in return? It compressed the gas on the right-hand side. And the right-hand side gas is an adiabatic thing. So all the work became internal energy, delta U2. Is this making sense? So end of the day, can I say like this? The total heat that you supply is nothing but internal energy of both the gases. Is that sentence making sense? Because where else is the energy going? Whatever I'm giving you, internally, right? The volumes are changing, but that is all internal work. So all the heat that I'm supplying is simply going into internal energy delta U1 plus delta U2. So this is NCV T1 minus T0 plus NCV T2 minus T0. There, you know the value, substitute and get the answer. Is this clear, everyone? Sure. Let's see one more. This is another variety of problems. A little different, but end of the day, still, if you see using the formulas, there, let's get this. I think if you got this, you understood. 3 compartments. Question itself looks big, you know. Would heat be equal to work plus internal energy? And the work is 0. You can say like that. The total volume didn't change, right? So total volume didn't change. It's simply there is work done basically. The left one gave something to the right. So internally everything is inside only. Read the question carefully. Diagram is given. There are 5 parts to the question. All are connected. You will get one after another, but figure it out. Like he keeps saying, drawing the final diagram is the key. Let's try. I'll give you 4-5 minutes. I'll give you 4 minutes, 3 minutes, and then I'll show you one part. You try whatever it is, then I'll give you a little more time. Let's see the diagram first. Like I keep saying, if you really don't understand how that final thing looks like, there is nothing you can do about it. The figure shows an insulated cylinder divided into 3 parts. There are a lot of things in this. I need that question at any point of time. So let's keep it like this. Piston 1 and 2 are connected by rigid rod. So this is a rigid rod. So can I say like this? Volume in B remains constant. Meaning do whatever you want, volume in B won't change. Piston 1 is perfectly conducting. So that means the temperature between these two will remain same. Temperature in compartment A will be equal to temperature in B. While the piston 2 is perfectly insulating. Means container C is going adiabatic expansion. Compartment C is adiabatic process. Adiabatic compression. Incident state present in compartment blah blah blah. Now compartment A is given slowly heat. Final volume of C becomes 4V naught by 9. Okay. Let's draw the new diagram. It looks like this. This is that rod. So pressure will be how much? Let this be P1. This also will be P1, agreed? Compartment 1 and 3 will have same pressure, or else the piston will move. This pressure will be different, P2. Let this temperature be T1. This will be T1. This will be T2. Have a look at this. 1 and 2 ka temperature is same. 1 and 3 ka pressure is same. This volume is V0. This guy is 4V0 by 9. And this guy is whatever decrease there should have increased in the first one. So that is V0 plus 5V0 by 9. V0 plus 5, 9 plus 5, 14 V0 by 9. Check. Is the diagram clear? And what is doing? I just know the volume. Fair enough. T2 आ जाएगा ना यहाँ से. P भी आ जाएगा. I'll get a lot of things from here. So let's find the pressures first of all. Take the C compartment. Compartment C. Gamma is 1.5. So PV power gamma. So P naught V naught per gamma minus 1 is equal to final pressure is P1. Volume is 4 V naught by 9. Gamma minus 1. This is P naught. This is P1. V naught will cancel 4 by 9. That is 2 by 3 ka square. Gamma minus 1. Gamma is 1.5. That is half. 2 will cancel. P1 will be 3P naught by 2. Clear? P1 आ गया. Then once I got P1, go to the compartment A. In compartment A, P naught, V naught by T naught will be pressure is P1, which is 3P naught by 2. Volume is 14 V naught by 9 by temperature T1. P naught, V naught will cancel. So I'll get T1 will be 7 by 3 T naught. 3 3s are 2 7s are. T1 आ गया? Yes. Did I get that volume right? 14 plus 8, 9, 2 naught, that is right. I got T1. What else do you need to find? I need to find P2 and T2 also. Actually, compartment C, I can do this also. In compartment C, P naught, V naught by T naught is P1 is 3P naught by 2 into 4V naught by 9 by T2. From here, I'll get T2 is equal to 2 T naught by 3P naught by 2, 4V naught by 9, 2T naught by 3. And C used TV power gamma minus 1. Because even I thought temperature will be more. Because you're compressing, temperature should increase until unless I goofed up the calculation somewhere. Is P1 right? Mm, mm, mm. Threes are, twos are. 2/3 का square. अरे यार, what should I did? ये PV पर gamma is constant ना? That is PV per gamma minus 1 na? That is PV per gamma is constant. I did everything wrong. So this is 2 into 3/2. That would be 2 cube by 3 cube. So 8 reverse में होगा. That would be 3 cube ना 27 P naught by 8. Clear? That is a mistake I did. So then this will be 27 P naught by 8 into 14 P naught by 9 into T1. यहाँ से T1 आ जाएगा. How much is that? 3, 21 T naught by 4. 9 3s are, this is 2s are, 7s are, 7 3 21. ठीक है. In compartment C, P naught V naught by T naught. Pressure would be 27 P naught by 8. Volume would be 4 V naught by 9 by T2. This is 4 2s are. That is 9 3s are. 3 T naught by 2. Via? That would be right. और क्या चाहिए? I got P1, I got T1, T2 temperatures, I got everything. अभी P2 करना था. That you can take for compartment B. In compartment B, again same story. P naught V naught by T naught. So basically all mole conservations. P2 I don't know. That's what I want to find. Volume will remain same. Temperature is T1, which was 21 T naught by 4. So P2 would be 21 P naught by 4. There. सब जगह pressures आ गया. A and B I got. What is work done by gas in A and B? Work done on B कितना होगा? 0 ना? The volume is not expanding. Have a look at this. Is this clear, everyone? Then comes the second part. All clear? Can I go ahead? This will be an advanced paragraph. A little long. They might not ask you so many questions. So once I got all this, what is the heat supplied? Heat supplied is simply change in internal energy in the compartment 1, internal energy in compartment B, internal energy in compartment C. Does it make sense? Total work done is 0. Internally जो भी है. So whatever you're supplying is used to increase the temperature of all the gases. That is your C part. Done. What is work done by gas on A? So work done on B is 0. Isochoric. Volume didn't change. You want work done on gas A. Can I say like this? Whatever work you're doing on this compartment, where is this going? Isn't this used to compress only this gas? See, I will give you the timeline. You will tell me from there. The heater is giving the heat. This was taken by compartment A. Compartment A took some of the energy and made its own internal energy. Then from compartment A, some heat flowed through the piston. The heat flowed through the piston. And some of it went into work done on compartment C because it compressed the gas C. This heat that went into the piston became delta U2. This work done by the C became delta U3. Does the distribution make sense? See, when I push the piston, does the middle compartment compress? That means all the compression should go into the third compartment only, no? On top of it, because the piston is conducting, some heat will flow through this piston. So whatever energy you're getting, you're sending some heat through the piston. And see, this is insulated, isn't it? This is insulated, so heat to can't flow here. So matlab first piston say whatever heat went, that just went through the first compartment and went into the second compartment. And work done went into the third compartment. Is that making sense? The advantage of writing like this, there is no need to find individual formulas. Now in the first compartment, you want to find the work done integral PdV. How will you do that? Do you know what process is there in the first compartment? Vihan? You don't know what process. You can't use P delta V. Pressure is not constant. We don't know what process is the first compartment. We can't solve. But look at this distribution. It makes your life so easy. It clearly tells you where the energy is always getting distributed. Please check out the thing in the green one. Ask me if you're confused with that. These kind of questions, whenever they ask you heat or energy, this is the way to do. Ask yourself, the heater gave heat, A took it. What did A do? It took some of the energy, made delta U. Remaining energy, some went through the piston and went to compartment 2. Remaining energy pushed the piston and compressed the gas 3. Make sense? Now, with this idea, if you see what is work done on A then? Work done on the piston is nothing but delta U3. Isn't it? And done. What is the heat flowing through the piston? This is your D part. This is your C part. What is E part? Heat flowing through the piston, that is delta U2. Once you know the temperatures, you can find delta. We get this distribution total. Yeah, you should get total work done 0, na? Total volume constant है ना record. कहीं पे भी volume change नहीं हुआ. And think of like this: the whole system is insulated, isn't it? Whatever is happening is all internal. You're pushing me, I'm pushing you. All this energy is simply getting redistributed. Is this clear, everyone? Pretty good one. You should definitely try this on your own again without seeing once. Especially, right? This is the important one. If you ask me, how did the heat get distributed? Clear, everyone? Clear, na, Ansh? Adi? Ishana? Devika? Clear? Niharika? Arya? Arush? Soham? Ojas? Sharman? Vignajit? Surya? Clear? Jainil? Perfect. Next thing. Reversible and irreversible processes. What is a reversible process? I'm sure you studied this in chemistry. We'll not go so deep into it. We will just I'll explain you the basics. You should know that. So who is missing? Someone left the class. Okay, let's see. What's a reversible process? A process is said to be reversible if the system undergoes similar states while coming back from final to initial state. I'll tell you what it means. Physics may really not that important, just an idea is important. Now, the thing is, imagine you take a compartment. Temperature is T0. Let's say temperature is T. Now, if I put heat Q inside, what do you think will happen? I'll give you a more crude example. See, what is a reversible and irreversible process? Think of like this. Let's say I come into your classroom and let's say there are 30 students in the class and I bring 30 chocolates. What do? I keep them in the first bench. Right, you all are sitting here. I keep it in the first bench and I say, everyone take one chocolate and I go away from there. What do you think will happen? People from the first bench will jump inside. This guy will take 2 chocolates. This guy will take 4 chocolates. Second bench people will come. Someone will take 5 chocolates. Everyone will start fighting. But then because I told everyone should get 1, right? And then, you will start giving back 1, 1, 1, 1. Maybe I'm there and watching you, so you will give back everyone. Eventually, all will get 1, 1 chocolate. Technically, you should get it. If you eat that, I don't know. Everyone will get 1, 1, 1. Okay? Now I come and say, sorry, I forgot. These chocolates are not for you. I have another better chocolates for you. Now I bring back that empty box and say, put back the chocolates. Do you think with the same enthusiasm, these people will jump and put back 3, 4 chocolates? Did you see the way the chocolates went away to you? The same way I can't bring the chocolates back into the box. This is an irreversible process. But how to make it reversible? Think of like this. I come to you with a box of chocolate. I hand over 1 chocolate to you. I hand over 1 chocolate to you. I hand over 1 chocolate to you like this. Now I can go back and again take back 1 chocolate from you, 1 chocolate from you, the same way. The way I gave you 1 chocolate to each one, I can go back and take back the chocolates in the same process. This is a reversible thing. Getting the analogy? So when you say reversible and irreversible, in a reversible, right, when you go from A to B and B to A, the steps should be similar. Now, for example, look at this thing. Let's say we got a compartment, you just gave certain heat Q. Tell me one thing, if I give heat Q, do you think the whole compartment will suddenly become, temperature will rise? When you switch on the AC, which part of the room will cool down first? The area near the AC, isn't it? So the room temperature is not constant. So this is what will happen. The moment you give heat Q, suddenly here temperature will be 3T naught. Here it will be still T. Here it is maybe, some here also maybe it is T. Maybe 2T or something like this. So then as time passes, maybe this will be 2.5T, right? Maybe this is 1.5T and maybe this is 2T. And eventually the whole compartment becomes 2T. You getting what is happening? Now in this process, temperature is undefined. Pressure is also undefined. Because see, the whole thing, this is in a non-steady state. It's still in what you call it has not reached equilibrium. This is not an equilibrium. So during this process, temperature is undefined. You can't use any of your ideal gas equations. PV is equal to NIT. All the things that you learned are wrong. Nothing works. Making sense? Finally, everything will settle down and get temperature 2T. Now what I will do, I will cool it down. Now what you did, you removed heat Q from here the same way you gave heat Q. Now what will happen? The moment you remove the heat, here the temperature would be, let's say, T by 2. Here it will be still T. Here also it will be still maybe T. Getting it? Or maybe it is 2T naught, and here also it is 2T. Then after some time, this will become maybe 3T by 4. And this will become 3T by 2, and maybe this becomes T. And finally, you get back the same temperature. Did you notice something? The way I went, did I get back the same way? Making sense what I'm saying? This is an irreversible process. And the biggest problem with this thing is, momentarily for some time, the states become undefined. And if they're undefined, that means you can't use ideal gas equation. If you can't use ideal gas equation, I can't solve anything. Clear? So states from A to B and B to A are not identical. Unfortunately, real life, all the processes are irreversible. So how do you make a reversible process? We can't exactly get a reversible process, but we can get pretty close to it. This is what we do. Instead of giving so much heat at once, we keep giving dq, very small amounts of heat. We call this thing quasi-static process, if you ever heard that term. Quasi-static. Static meaning it's almost in equilibrium. Quasi meaning momentarily equilibrium, meaning it is getting disturbed, but it comes back to equilibrium in a very small time. So we can neglect that thing for a moment. So initially temperature is T naught, T, let's say. So instead of giving a huge amount of heat, you give a very small amount of heat. That is the main thing. Because it doesn't follow the same steps. A to B and B to A steps are not same, so it is irreversible. So if I give small heat dq, what will happen? Temperature everywhere will change by small time dt, small temperature dt. So this is the catch. Even this is an approximation. Because you're giving such a small negligible heat, we can assume the temperature also will change very small. So it's almost an equilibrium. Then you give again small heat dq. Then this will be T plus 2T. Again dq and so on. Finally, you'll get 2T. But the problem with this process, it will take infinite steps. Therefore, it will take infinite time. Therefore, these processes don't exist in reality. These things you can study, but they don't exist. Reversible process exists, but we can't study irreversible things. The same way, when you want to cool it down, remove heat dq. This will be 2T minus dt. Sorry. T plus 2T. Remove dq. T plus dt, and you're back. These kind of processes, right, are called quasi-static process. We can assume it is in steady state every instant because the dq is very small. If it is in steady state, pressure and volume are defined. Pressure and volume are defined, then you can use ideal gas equation, then all the formulas we studied will come. It is in steady state. Right, for a small instant, we can assume it is in steady state. The problem with this thing, this would take infinite steps. So dq is very small. So the smaller the dq, the better this will be. So if you want perfectly reversible process, you need to get infinite dq. So it will never happen. dq tends to 0. It takes infinite time. Yeah, that's it. In physics, we don't need to learn more than this. So that is the main idea there. So most of the processes in real life are irreversible. That is fine. You understood that. Clear this? So that is reversible and irreversible. So I'm sure chemistry must have heard about it. But that is so for physics, that is the thing you need to understand. In irreversible, you can't define that thing, so we can't study. So other than that, physics made really not a big deal for us. Clear? So there, that is about the first law. Now after this, we have second law. In second law, we have heat engines and all, but now that is removed from the portion. In mains, they removed it this year. Advanced this year it is there. But next year it will be there or not, we don't know. But we are going to still do it because it is there in boards. Bits mein abhi tak it is still there. So till we know, better we will assume it is there and we'll finish it off. The next class when we catch up, we will do that. It's not a big thing. It's just one formula. The derivations are not there. And maybe 3-4 problems are there. I think it should take another 45 minutes, 1 hour. We should finish it off. Second law will be done. And we will do also about little about entropy, but it will not be that extensive like in chemistry. For us, the entropy problems are very easy. So next class when we catch up, we will do the heat engines and we will do entropy, right? And then second half of the class, we'll start off with heat transfer. So we'll start with conduction. So thermodynamics, if you see, the main thing is that only. You saw the models, right? As long as you know the process. But these problems you should have seen. If you ask me out of all, these are with the tougher ones. This piston moving, heat is coming, and all this nonsense. So make sure to resolve them, go through them once. You can start solving your material because I think heat transfer will take another three classes maximum. We'll finish off heat transfer also. It's not a big one. It kind of looks like current electricity, resistance in series and parallel for the first half. Okay, with that, we'll wrap up for the day. So I'll catch up again next Tuesday at 5:40 as usual. So any doubts, anything you can stay back and ask. The test is online till tomorrow. Make sure to give it. So any doubts, anything you can stay back and ask.